Now that we know how to name three-dimensional figures and we have a little bit of information about how to draw the nets, what the nets are, that sort of thing, we're next going to talk about surface area. Surface area really is what it sounds like. It is a measure of the area of all of the surfaces of a three-dimensional figure. So imagine it's kind of like the idea of wrapping a present, except we would want to cut the paper to match every face exactly and not have any layering or folding or anything like that. We want it to just fit perfectly. So, for example, if we wanted to wrap something that looked like this particular rectangular prism here, we would have to cut a piece that was a piece of paper that was 7 meters by, notice this is 15 meters, and that would cover this side. And then we would have to do one that was 6 meters by, take a look at what that one's going to be. That's going to be 7 meters because that's going to connect with this face right here. So 6 meters by 7 meters. And that would cover the side right here, cover that face. And then if we want to cover the top, we're going to do one that is a piece of paper that's 15 meters because it matches this one by 6 meters because it's going to match this one, that edge. So that's going to be a rectangular face that's going to measure 15 meters by 6 meters. And then once I did that, keep in mind this is a three-dimensional figure. And since it's a rectangular prism, that means I'm actually going to have 6 faces, not just 3. So notice I'm going to have a back and a front that are congruent, 2 sides which are congruent, and the top and the bottom which are congruent. Now, you can do this one of 2 ways when you're thinking about how you want to find the total surface area. You can either draw a net, which a net of this figure would look something like this, where you would have, let's see, something right about here that are going to be your sides where they were folded up. And then all of this, whoops, it's going to look something kind of similar to this, maybe. So notice we're going to still have 6 faces. 1, 2, 3, 4, 5, 6. The trick is going to be actually labeling all of them correctly. This length is going to be 15 meters. This is going to be your 7 meters. And this is going to be your 6 meters. So notice when I would put that together that when I actually folded it up, this edge is going to fold against this edge, which is going to make this 7 meters, just like this one has to be 7 meters because it matches this one. So I could go around and I could label every single edge, and it would help me figure out the length and widths of each part of this. What I could also do, if I wanted, is I could do what I call, it looks a little bit like this idea. This is a listing if, let's say, I wanted to build something out of blocks, and it tells me how many of each kind of block I need. So instead of putting listing all of them out and having some of them be repeats, it just puts each of them once and tells how many that I need. I could do something similar with this. For example, I could say, well, the front and the back both look like this. The front and the back are each 15 meters by 7 meters. So I'm going to need 2 of those because, again, that's both the front and the back. And then when I look at the top and the bottom of that figure, the top and the bottom are going to be kind of like that, but not exactly. They're not congruent to those. It's going to be 15 meters by 6 meters. And again, I'm going to need 2 of those because one is going to be the top and one is going to be the bottom. And then I'm going to need the sides, which are going to be each 6 meters by 7 meters. So 7 meters by 6 meters. And again, I need 2 of those because those are my sides, and I have 2 of those. So now, if I want to find the surface area, I can find the area of each face. And remember, when I do the front, I'm going to have to double it because I need one for the back also. When I do the top, I'm going to double it because I need one for the bottom also. When I do the side, I'm going to double it because I need one for the side also. You could also organize all this work into a chart. For example, I could say that the top and the bottom I know were both 6 meters by 15 meters. So I could look back and say 6 meters by 15 meters. And 6 times 15, and the reason I'm doing 6 by 15 is because they are rectangles. So I'm doing area equals base times height. So I'm going to do 6 times 15, which is 90 square meters. And the bottom is also going to be 90 square meters. When I look at the sides, those were each 6 meters by 7 meters. So I'm going to do, because they're rectangles, area equals base times height. So area equals 6 times 7, which is 42 square meters. And I'm going to put the same thing for the other side because I know that those opposite faces are congruent. And then the front is going to be, I noticed it was 7 meters by 15 meters. It was a rectangle, so I'm going to do the area of that face. I'm going to do base times height, so I'm going to do 7 times 15, which is 105 square meters. So the back and the front are both 105 square meters. Now if I want to find the total surface area, all I need to do is add up all of the areas of each of the faces. So I'm going to add together 90 square meters plus 90 square meters plus 42 square meters, 42 square meters, 105 square meters, and 105 square meters. When I add all of those up, I'm going to get 474 square meters as my total surface area of that figure. Now, sometimes you may have a figure where you have to where you're already given the net, and if you're given the net, that's actually easier because you can then you can just look at the dimensions where they are on the net and you can see the faces that way. So here's an example of that. Let's look at problem number 1 that you see over here. When you look at this, and the numbers may be a little bit hard to read, so I'll tell you what they are. I'm going to look first at this triangle, and when I look at that triangle, I know that the formula for area of a triangle is area equals base times height divided by 2. Well, that particular triangle has a base of 6 feet and a height of 6.4 feet. That's this measurement right here, 6.4 feet. I'm going to divide that by 2, and I'm going to get 19 and 2/10 square feet. Notice that triangle is congruent, that triangular face is congruent to this one. So this one is also going to be 19 and 2/10 square feet. Then I'm going to look a little bit more, and I'm going to see, well, here's another triangle, but it's not congruent to those other two. So I still need to use my area formula. Area equals base times height divided by 2. So I'm going to do a base of 10 and a height of 5. So 10 times 5 is 50, divided by 2 is 25 square feet. This triangle is congruent to that, so this one is also 25 square feet. And then last but not least, I have a rectangle here. This rectangle, this rectangular base, I have to do a base times height for area of a rectangle. And this rectangle is 6 feet by 10 feet. And so that's going to give me 60 square feet. And my last step is I need to go through and add all of my areas. There are 5 faces, so I should have 5 numbers. I'm going to have 19 and 2/10 square feet, 25 square feet, another 19 and 2/10 square feet, 60 square feet, and 25 square feet. And when I add all of that together, I'm going to get 148 and 4/10 square feet as the total surface area for that figure. And that particular figure, by the way, if I folded it up, it would make a rectangular pyramid, and I know that because all but one of its faces are triangles, and the one that's not a face is a rectangle. So the base is a rectangle, the lateral faces are triangles. That makes it a rectangular pyramid. Give these others a try, number 2, 3, and 4, and see if you can figure out the areas, the surface areas rather, of those nets, and also what they would, what figure they would make. When you're done, check your work and see what you get. All right, when you looked at those, here are your answers. whoops, I have that first one wrong. The first one is going to be again, the 148 and 4/10 square feet. And that last one was a little bit hard. It was trapezoidal prism, and it's a trapezoidal prism because if you notice, most of the faces are rectangular, which makes it a prism. It's trapezoidal prism because of the other two faces, the two bases, which are going to be our trapezoids. It's trapezoidal prism. Surface area is not hard. It really is just more tedious than it is hard, and you need to go through and make sure you include all of the faces. Make sure you use the right formulas and the right measurements for each face. But the concept itself, not too hard, just a lot of steps.